In this session, we are going to discuss the topic probability. The word probability, which is synonym with the word chance, is very frequently used in our day-to-day life. This word probability is used in a broad sense to indicate that there is a possibility of something to happen. For example, if I say the chances of you being selected as a probationary officer in a bank are high. Now here I am trying to say that it is possible that you can get selected as a probationary officer in a bank. So in this topic of probability, we try to measure the possibility of different events. Before we learn how to measure the probability of a particular event, we should understand some important terms related to probability. So let's have a look at them. The first one here is random experiment. Now before we take random experiment, let us understand what is meant by experiment. Experiment in general is nothing but an operation or an event which has got some well-defined outcomes. Let us now see what is meant by a random experiment. Random experiment, an experiment whose outcome or result cannot be predicted even though all the possible outcomes are known in advance, is called a random experiment. So here, as the definition says, a random experiment is the one in which the outcome or the result cannot be predicted even though all the possible outcomes are already known to us. Such an experiment can be taken as a random experiment. For example, tossing a coin or throwing a dice, etc. All these are called random experiments. Now when we toss a coin, we know that there are two possible outcomes. Either it can show a head or it can show a tail. Now even though we know that there are two possible outcomes, head or tail, we cannot predict what exactly will be the outcome or the result when a coin is tossed. So even though a coin is tossed n number of times under the same conditions, predicting the output at each of these instants is not possible. The other example that we have seen here is throwing a dice. Now we know that a dice has got 6 faces where each face is numbered from integers 1 to 6. So the 6 possible outcomes when we throw a dice or when we roll a dice are 1, 2, 3, 4, 5 or 6. So we very clearly understand that the output will be any of these 6 integers. Now even though we know that these are the 6 possible outcomes, we cannot predict what exactly will be the output when a dice is thrown. So all such events where the output cannot be predicted even though all the possible outcomes are known to us are called as random experiments. So in the study of probability, we always take random experiments into consideration and try to measure what is the possibility or what is the chance of a particular outcome to occur when an experiment is conducted. Now the next point that we need to understand here is sample space. The set of all possible outcomes of a random experiment is called a sample space. And usually it is denoted by the letter S. So sample space is nothing but the set of all those outcomes which can result for a given random experiment. For example, we know that when we toss a coin, there are two possible outcomes, either a head or a tail. So the sample space for tossing a coin will be head or tail. So this is the sample space for tossing a coin. Likewise, when we throw a dice, the sample space can be taken as all those possible outcomes 1, 2, 3, 4, 5 and 6. So these are the 6 possible outcomes when we throw a dice. So this can be taken as the sample space for throwing a dice. And in this sample space, each of these outcome is known as a sample point. For example, there are 2 sample points for tossing a coin. It can either be a head or a tail. So the possible outcomes are known as sample points. And the set of all these sample points is known as sample space. So head and tail are the sample points for the sample space of tossing a coin. Likewise, when we throw a dice, we know that the sample space is 1, 2, 3, 4, 5 and 6. Now each of these elements here is known as a sample point. So sample point is nothing but a particular outcome for an event. And set of all possible outcomes is known as sample space. After learning about random experiment and sample space, let us now understand how to measure the probability of occurrence of an event. The probability of an event E is denoted as P of E, and in general probability of an event lies between 0 and 1. That is, the minimum probability is 0 and the maximum probability is 1. For an event which is impossible to happen, the probability is 0, and for an event which will definitely happen, the probability is taken as 1. For example, let's say that we have a biased coin which has got heads on both the sides. Now when we toss such a coin, what is the probability that the outcome is head? We know that the definite outcome there would be head. Why? Because on both the sides we have head here. So we say that the probability of head here is 1. That is the maximum probability. And similarly, for such a coin, what is the probability that the outcome is a tails? Now here, the probability should be taken as 0. Why? Because we know that tails cannot appear for a coin which has got heads on both the sides. So probability for a definite event should be taken as 1 and probability for an impossible event should be taken as 0. And in general, probability of an event always lies between 0 and 1. Let us now see how to measure the probability of an event. Now as we know that probability of an event is denoted as P of E. So P of E is equal to the number of favorable outcomes by total number of outcomes. We have already learned what is meant by sample space. Sample space is nothing but set of all possible outcomes for a random experiment. So out of all those possible outcomes, the probability of a particular type of event to happen can be taken as number of outcomes which are in favor of that event divided by the total number of outcomes. So number of outcomes which are in favor of the event can be taken as N of E, and the total number of outcomes is nothing but all the sample points of the given sample space, that is N of S. So in general, probability of an event can be taken as the number of outcomes which favor that event divided by the total number of outcomes. So we can say that P of E is nothing but the probability of success of a particular event. Now how to measure the probability of failure of that event? That can be taken as P of E dash or P of E bar, which is equal to number of unfavorable outcomes divided by total number of outcomes. So here this is called probability of failure, where we see what is the chances that this particular event will not happen, which can be taken as N of S minus N of E divided by N of S. That is nothing but number of unfavorable outcomes. Number of unfavorable outcomes are total number of outcomes minus number of favorable outcomes. So total number of outcomes is N of S minus number of favorable outcomes is N of E. That divided by total number of outcomes again is N of S. So when we simplify this, we see that the probability of failure of an event or the probability that a particular event will not happen will be equal to N of S by N of S minus N of E by N of S. Now N of S and N of S gets cancelled. So we get 1 here minus N of E by N of S is nothing but the probability of the event to happen. So we can see that the probability of failure is equal to 1 minus the probability of success. So from this we can say that probability of success plus probability of failure is always equal to 1. So for any given event, the probability that the event will happen plus the probability that the event will not happen should be equal to 1. So probability of success of an event plus probability of failure of an event is always equal to 1. So this is how we can measure the probability of a particular event to happen and the probability of that event not to happen. Probability of an event to happen is taken as number of outcomes which are in favor of that event divided by total number of outcomes. And probability of failure of that event or probability that the event will not happen can be taken as 1 minus probability that the event will happen. Let us take an example to understand these points. We know that when we toss a coin, the sample space is head or tail. Sample space here has got two possible outcomes. Either it can be a head or a tail. So what is the probability that the output is a head? Now we know that probability of a particular event is nothing but the number of favorable outcomes by total number of outcomes, or number of outcomes in favor of the event divided by number of outcomes in the sample space. So probability that the output is head here should be taken as 1 by 2. Why? Because out of these two outcomes there is only one outcome which is in favor of the event. We want a head to occur and that can happen only in one way. So 1 divided by total number of outcomes are 2. Now what will the probability that the output is not a head? That is the probability of failure. This is the probability of success. What is the probability of failure? It can be taken as 1 minus probability of success. So 1 minus 1 by 2, which is equal to 1 by 2 again. So we can say that the probability that the output is head is equal to 1 by 2, and the probability that the output is not a head is again equal to 1 by 2. Now the output is not a head means what? It has to be a tail. So that is nothing but the probability of a tail. So total probability again, if you try to observe, probability of success plus probability of failure should be equal to 1. So here we see that the probability of tail or probability of outcome not to be a head is equal to 1 by 2. Why? Because if the output should not be a head, it has to be a tail. That can happen only in one way, divided by total number of outcomes, which is 2. So we can see that the probability of success 1 by 2 plus probability of failure 1 by 2 is equal to 1. So that is how we say that probability of head plus probability of not a head can be taken as 1 by 2 plus 1 by 2, which is equal to 1. That is the total probability. So always for a given event, the probability of success plus probability of failure should be equal to 1. Sometimes instead of directly giving the probability of success or the probability of failure of a particular event, the odds in favor of the event or the odds against the event are given. So let us see what is meant by odds in favor of an event or odds against the event. Let's say the probability of success of an event E is P of E, which is given as N of E by N of S. That is nothing but the number of favorable outcomes by total number of outcomes. Then the probability of failure of the event E is P of E bar, which is given as N of S minus N of E by N of S. That is nothing but the number of outcomes which are not in favor of E divided by the total number of outcomes. So the first one here is the probability of success, and this is the probability of failure. Now instead of directly giving the probability of success or the probability of failure of an event, the odds in favor of the event or odds against the event are given. So let's understand what is meant by odds in favor and odds against the event. Now odds in favor of an event E is equal to the probability of success divided by the probability of failure. P of E is the probability of success. P of E bar is the probability of failure. So odds in favor of an event is nothing but probability of success divided by probability of failure. So that can be taken as number of outcomes which are in favor of the event divided by the number of outcomes which are not in favor of the event. Likewise, odds against the event E is equal to the probability of failure of the event divided by the probability of success. So this can be taken as N of S minus N of E by N of E. That is the number of outcomes which are not in favor of the event divided by the number of outcomes which are in favor of the event. So odds in favor is nothing but number of favorable outcomes by number of unfavorable outcomes, whereas odds against is number of unfavorable outcomes by the number of favorable outcomes. Let's take an example to understand how to measure the probability of success or probability of failure when the odds in favor or odds against are given to us. For example, let's assume that odds in favor of a particular event are 3:4. Generally, odds in favor or odds against are given in the form of ratio 3:4. So odds in favor is equal to 3:4. That means here there are 3 outcomes which are in favor of the event and 4 outcomes which are not in favor of the event. So how do we get the probability of success from this? So the probability of success can be taken as, we know that probability of success is the number of outcomes which are in favor divided by total number of outcomes. Now from the ratio we know that because these are odds in favor, the number of outcomes which are in favor are 3. So 3 divided by total number of outcomes are 3 plus 4. Outcomes in favor plus outcomes not in favor. So 3 plus 4, which can be taken as 3 by 7. So the probability of success from this can be taken as 3 by 7. And once we know the probability of success is 3 by 7, we can see the probability of failure will be 1 minus 3 by 7. That is equal to 4 by 7. Likewise, let's say odds against an event are given to us. Odds against a particular event. Odds against are, for example, 2:5. So when odds against an event are given as 2:5, it is very clear that 2 represents the number of outcomes which are not in favor of the event and 5 represents the number of outcomes which are in favor of the event. Why? Because these are odds against. So unfavorable outcomes is to favorable outcomes. Now from this we can say that the probability of success or the probability of failure, let's say the probability of failure can be taken as, since 2 outcomes are not in favor, we can say the probability of failure is 2 divided by the total number of outcomes, 2 plus 5, 7. So that can be taken as the probability of failure, 2 by 7. Now once we know the probability of failure 2 by 7, we can say that the probability of success will be 1 minus 2 by 7. That is equal to 5 by 7. So this is how we can find out the probability of success or the probability of failure as it is required from the odds in favor or odds against a particular event. So simply remember that odds in favor is a ratio which shows favorable outcomes is to unfavorable outcomes. So probability of success should be favorable outcomes by total of these 2. And probability of failure should be unfavorable outcomes by total of these 2. Likewise, odds against shows unfavorable outcomes is to favorable outcomes. So from this, probability of failure can be taken as the number of outcomes which are not in favor divided by sum of these 2. That is 2 by 2 plus 5. And the probability of success can be taken as favorable outcomes by total outcomes. So 5 divided by 2 plus 5 can be taken as the probability of success. Let us now take the first model from the topic of probability, where we shall discuss questions related to tossing of coins. Let's have a look at the first example. When 2 coins are tossed simultaneously, what is the probability that both the coins show heads as the output? So here, as you can see, 2 coins are tossed simultaneously and we need to find out what would be the probability that both the coins show heads as the output. We very well understand that when one coin is tossed, there are 2 possible outcomes. It is either a head or a tail. So the sample space for tossing a single coin is head, tail. But here two coins are tossed simultaneously. So let us first decide what is the sample space for such an event. Now here the sample space can be taken as follows. The first coin may show up a head and the second coin can show tails. So that's one possible sample point. Then the second possibility here is first coin may show a tail and the second coin shows head. The third one is first coin can show head and the second coin as well shows up a head. And the fourth possibility is both the coins can show tails. So these are the four possible outputs or four possible outcomes when two coins are tossed simultaneously. First can show head, second can show tail, or first coin can show up a tails, second coin can show up heads, both the coins can show up heads, or both the coins can show up tails. There is no other possible outcome apart from these four outcomes. Now here we need to find out the probability that both the coins show heads as the output. So we have to find out the probability of both the coins showing up heads. That is nothing but both have to be heads. Now we know that probability of a particular event E is the number of outcomes which are in favor of that event divided by total number of outcomes. Now from the sample space, the number of outcomes which shows both heads is only 1. So we can say that the number of outcomes in favor is 1 divided by total number of outcomes here is 4. So we can say that n of s should be equal to 4. So the probability that both the coins show up heads is equal to 1 by 4. So this is how we can solve questions based on tossing of coins. We first need to decide what is the sample space, and then we can take up those outcomes which are in favor of the given event divided by total number of outcomes to get the required probability. Likewise, let's say what is the probability that both the coins show tails. Now again we see that there is only one outcome in which both the coins can show up tails out of total 4. So the answer here should be taken as 1 by 4. Suppose we have to find out the probability of one head and one tail. That means one coin has to show up head and the other coin has to show up tails. So what is the probability that this event can happen? Now from this sample space, we find that one coin showing head and the other coin showing tails can be happening in two possible ways. Either the first one can show up heads, second one can show up tails, or the first one will give tails and the second one will give us heads. So these are the two favorable outcomes out of total 4 outcomes. So the probability of one coin as heads and the other coin showing up as tails will be equal to 2 by 4. But because there are two outcomes which are in favor of this event divided by total 4 outcomes. Remember, we cannot take these two outcomes as the favorable outcomes. Why? Because here we find both heads and both tails. But the question says we want one head and one tail. So these are not the favorable outcomes, whereas the first two are favorable. So 2 out of total 4, which can be taken as 1 by 2. Likewise, what is the probability that both the coins show the same output? Probability that both shows same output. Both outputs are same. Let's take this. Both outputs are same. That means either both the coins should show heads or both the coins should show tails. Now, how will we get the answer in this case? Now here, to get the answer, we need to find out those possible outcomes in which both the outputs are same. Now out of these 4 outcomes, we find that there are 2 ways in which both the coins show the same output, both heads or both tails. In the first 2 cases, we find that one is head, the other is tail. So these 2 cannot be taken as favorable. Now these 2 become the favorable outcomes. So again the answer here is 2 out of total 4. Why? Because these are the 2 possible outcomes which are in favor of the given event out of total 4. So 2 by 4 is again 1 by 2. So this is how various questions from probability can be answered based on tossing of coins. We simply have to decide what is the sample space and then take up only those outcomes which are in favor of the given event divided by total number of outcomes to get the required probability. Before we take up the next example, let me add one very important point here. That is about what will be the total number of outcomes in the sample space. As you can see here, for such an event, the sample space has got 4 possible outcomes. So how should we calculate the number of outcomes in the given sample space? We know that when we toss one coin, there are 2 outcomes. It can be a head or a tail. Now when there are 2 coins, there should be 2 power 2 outcomes. Why? Because first coin can show 2 outputs and the second coin can also show 2 outputs. So when we combine them together or both the coins are tossed together, we will get 2 into 2, 4 outputs. And those 4 outputs are as shown here. Likewise, let's say we are tossing 3 coins. In that case, the number of outcomes will be equal to 2 into 2 into 2. That is 2 power 3, or it can be taken as 8. So this is how we decide the total number of outcomes for a given event. Let us now take the second example from model 1, which is based on tossing of 3 coins simultaneously. Let's look at the question first. When 3 coins are tossed simultaneously, what is the probability that 2 coins show tails as the output? So here we are tossing 3 coins simultaneously and we need to find out the probability such that out of these 3 coins, 2 coins show up tails as the output. Now when 2 coins have to show tails as the output, it is pretty obvious that the third coin has to be a heads. Now to solve this question, we first have to see what is the sample space. That is all the possible outcomes when 3 coins are tossed simultaneously. Now the sample space here will be as follows. We can have all 3 as heads, or all 3 can be tails, or we can have a combination of 2 heads with 1 tail. And again, this can be arranged in 3 different ways. The first 2 can be heads and the third one can be a tails, or we can have a head, tail, head, or tail, heads and heads. And we can have the other outcomes as 1 heads and 2 tails. So the first coin can show up heads and the remaining 2 will show up tails. And again, these can be arranged in 3 different ways. One is head, tail, tail, or otherwise tail, heads, tail, or tail, tails and heads. So these are the possible outcomes when 3 coins are tossed simultaneously. We see that there are total 8 outcomes here. 1, 2, 3, 4, 5, 6, 7 and 8. All 3 can be heads, all 3 can be tails. Any 2 of them can be heads and the third one can be tails. So first 2 heads, third one tail, or first and last heads, second one tail, or second and third heads and the first one can be tail. Likewise, we can have 1 heads and 2 tails combination in 3 possible ways. Now here we are supposed to find out the probability that 2 coins should show tails as the output. So our desired event is that out of these 3 coins, 2 must show tails and 1 coin has to show up heads. We know that the probability of an event is taken as number of favorable outcomes divided by total number of outcomes. Now the total number of outcomes here are 8 and we only have to decide what are the number of favorable outcomes. Now favorable outcomes should have 2 tails and 1 head. Why? Because we are looking for 2 coins showing up tails. Now out of these 8 possibilities, we can have 2 tails in these 3 cases. That is first coin showing up heads, remaining 2 are tails, or first and last are tails, second one is heads, or the first and second are tails and the third one is head. And the remaining cases here are not favorable for the given event. Why? Because we want 2 tails and 1 head. So out of total 8 cases, we find that there are 3 possible outcomes which are in favor. So the probability here can be taken as 3 out of 8. So that's the answer for this question. But friends, as you can observe here, unlike the previous example, taking the complete sample space and then finding out the favorable outcomes becomes a lengthy task. Why? Because we have got 3 coins here. And 3 coins, as we know, will result in total 8 outcomes. Why? Because 2 power 3 should give us the total number of outputs. So that is 2 power 3 is 8. So we'll have total 8 possible outcomes. Now taking all those 8 outcomes in the sample space and then checking the favorable ones is a very tedious task. So let us see how can we get the answer without actually taking the sample space. Now we very well understand that probability of any event is nothing but number of favorable outcomes by total number of outcomes, as we have taken in the previous case. Now without worrying about the complete sample space here, we know that the total number of outcomes when 3 coins are tossed simultaneously should be taken as 2 power 3. Why? Because each coin will give us 2 outcomes. So when there are 3 coins tossed together, the number of outcomes will be 2 into 2 into 2, that is 2 power 3. Now the only concern here is what will be the number of outcomes which are in favor of the given event, that is 2 tails and 1 head. We know that total we have got 3 coins. Now here we have to select 2 coins out of these total 3 coins which can show tails. So that is nothing but selection of 2 coins out of total 3 coins. That can be done in 3C2 ways. But because once we select 2 coins which have to show tails, it is obvious that the third coin will be showing up heads. So it is simply 3C2 divided by 2 power 3. And 3C2 is nothing but 3 factorial divided by 3 minus 2. 1 factorial into 2 factorial. And this whole divided by 2 power 3. So this can be simplified as 3 factorial is 6 by 2 whole divided by 8. So that is nothing but 3 by 8. So that's how we can directly get the answer without taking the complete sample space. We only have to select 2 coins out of the total 3 coins which can show tails. So that is simply selection of 2 out of 3. In a similar manner, the probability that only 1 coin shows a tail can be asked. So here you can see that we need only 1 tail and remaining 2 have to be heads. So that is nothing but selection of one coin out of the given 3 coins which can give a tail divided by total number of outcomes. So there the answer can be taken as 3C1 divided by 2Q. Why? Because we need only one coin which can show a tail. 3C1 is equal to 3 divided by 2 cube is 8. So again we see that the answer is 3 by 8. And this can be justified by looking at the sample space. As you know, we need only one tail, and one tail here is these 3 cases. Here we have only one tail and remaining 2 are heads. Whereas in all the other cases we find more than one tails. So that is the reason the answer is 3 by 8. Similarly, the question may say, what is the probability that all the 3 coins have to show heads? Now here all the 3 coins have to show heads. That means we need to select 3 coins out of total 3 coins. So there it can be taken as 3C3 divided by 2 power 3. Remember, the total number of outcomes always remains same. Whatever be the event, total number of outcomes or total number of outputs is always 2 power 3. Only the numerator changes based on the given event. So since we need 3 heads, we can take it as selection of 3 coins out of all the 3 coins. That is nothing but 3C3. And 3C3, as we know, is equal to 1. Whenever R is equal to N, NCR should be equal to 1. So 1 divided by 8. So the probability that all the 3 are heads, or let's say all the 3 are tails, can be taken as 1 by 8. And this again can be justified from the sample space. As you can see, out of all the 8 outcomes, we have only one outcome where all 3 can be heads, whereas remaining all have less than 3 heads. So 1 out of 8 will be the answer. Likewise for 3 tails, again 1 out of 8 will be the answer. Let us now take the second module from this topic of probability, where we shall discuss questions related to rolling a dice or throwing a dice. Let's look at the first example here. When an unbiased dice is rolled, what is the probability that the output is? The first bit here is 1. Second bit is that the output should be 2. Third one is the output should be a prime number, and the fourth one here is that the output is greater than 2. So let's see how to solve these questions based on throwing a dice. Now we know that the sample space when we throw a dice is 1, 2, 3, 4, 5 and 6. That means these are the possible outcomes when an unbiased dice is thrown. Now the first question here says, what is the probability that the output is 1? We know that the probability of any event is the number of outcomes which are in favor of that event divided by total number of outcomes. Now from the sample space, we see that there is only one possible way of getting the output as 1. So we can say that the number of outcomes which are in favor of the output as 1 is 1 divided by the total number of outcomes here is 6. So the probability of getting the output as 1 is equal to 1 by 6. Likewise, in the second question, it says, what is the probability that the output is 2? Now here again, if you observe the sample space, we get the output as 2 only in one possible way. So there again, the probability that the output is 2 will be equal to 1 divided by 6. Be careful friends, here the answer should be taken as 1 by 6 but not 2 by 6. Why? Because the numerator is the number of outcomes which are in favor of the given event. That is, in how many ways can we get 2 as the output? We can get 2 as the output only in one way. So that is the reason the numerator should be taken as 1 and the total number of outcomes here is 6. So don't take the answer as 2 by 6. Because the output is 2, answer should not be taken as 2 by 6. It is the number of ways in which we can get the output, but not the actual output. So whether the outcome has to be 2 or 3 or 4 or 5 or 6, whatever be the output, probability is always 1 by 6. For example, what is the probability that we can get the output as 4? It should be taken as 1 by 6. Why? Because we can get 4 only in one way. So 1 out of 6 ways. So 1 by 6 is the answer. Similarly, what is the probability that the output is 5? Again, the answer should be taken as 1 by 6 but not 5 by 6. So remember that the numerator in case of probability is not the output but the number of ways in which we can get the output. Let's now move to the third one. The third one here says, what is the probability that the output is a prime number? Now here the event is that the output has to be a prime number. So how to get the answer for this one? So probability of finding a prime number. Now from the sample space, we need to find out what are those outcomes which are in favor of this event. That is, the output has to be prime number. Now out of all these 6 outputs, we see that prime numbers are 2, 3 and 5. That means if we get any of these 3 outputs, we are successful in getting a prime number. So we say that there are 3 outcomes which are in favor of getting a prime number out of total 6. So the answer for this question here should be 3 divided by 6. There are 3 ways of getting a prime number out of total 6 outcomes. So 3 by 6 is the probability, and this can be simplified as 1 by 2. Likewise, what is the probability of getting a composite number? Now out of the sample space, there are only 2 composite numbers, 4 and 6. So the probability of getting a composite number should be taken as 2 by 6. Why? Because 4 and 6 are the only outcomes which are in favor of getting a composite number. So 2 out of total 6. 2 by 6 is equal to 1 by 3. Be careful, 1 is not a composite number. 1 is neither prime nor composite. So don't take 1 in the category of composite numbers. Let's now look at the fourth one. The fourth question here says, what is the probability that the output is greater than 2? We want the output to be greater than 2. So what is the probability? Output greater than 2. Now when we want the output to be greater than 2, it can be 3 or 4 or 5 or 6. So there are 4 outcomes which are in favor of this event. So we can say the probability here is 4 out of total 6. 4 by 6 is equal to 2 by 3. So the probability that the output is greater than 2 should be 2 by 3. And the point that needs to be observed here is we have to be very specific while solving questions related to probability. Here the question clearly says that the output has to be greater than 2. So we cannot take 2 as a favorable outcome. Only when the question is about output greater than or equal to 2, then we can take 2 as a favorable output. So in this case, the answer should be taken as 5 by 6. That is nothing but probability of getting an output greater than or equal to 2. It can be 2 or 3, 4, 5 or 6. That is total 5 out of 6. Similarly, let's say that what is the probability of getting an output less than or equal to 4. Now from the sample space, we can see that the outcomes which are in favor of getting less than or equal to 4 are 1, 2, 3 and 4. All these 4 can be considered as favorable outcomes for such an event. So here the answer should be taken as 4 by 6, that is equal to 2 by 3. And similarly, if the question says output should be less than 4, then we take it as only 3. That is 1, 2 and 3 are the possible outcomes out of total 6 outcomes. So simply based on the sample space, we can solve such simple questions related to throwing a dice. So just decide what is the proper sample space, take those outcomes which are in favor of the event as the numerator and total number of outcomes in the denominator to get the required answer. Let us now take the second example from model 2. The question here is, when 2 dice are rolled together, what is the probability that sum of the outputs is 8? So as you can see here, 2 dice are rolled at the same time. We need to find out the probability of getting the sum of the outputs as 8. Let us first understand what will the sample space look like for such a case when 2 dice are rolled together. We know that the possible outcomes when dice 1 is rolled here is 1, 2, 3, 4, 5 and 6. Similarly, for the second dice as well, there are 6 possible outcomes, 1, 2, 3, 4, 5 and 6. But when 2 dice are rolled together, we will get total 6 into 6, 36 outputs. That is nothing but combination of each one of the outputs of dice 1 with every other output of dice 2. That is, we can have 1 with 1, 1 with 2, 1 with 3, 1 4, 1 5, 1 6 as the 6 outputs. So the sample space here will look as follows: 1, 1, 1, 2, so on up to 1, 6. That is combination of 1 as the output of dice 1 with every other output of dice 2. Likewise, we can have 2 as the output of dice 1 and 1, 2, 3, 4, 5 and 6 as the outputs of dice 2. So again we will get 2, 1, 2, 2 and so on up to 2, 6 as the outcomes when the output of first die is 2 with every other output of second dice. And similarly it can be taken as 3, 1, 4, 1, 5, 1, 6, 1 up to 6 and 6. So altogether we'll have 36 outputs or 36 outcomes in the sample space. Here we need to find out the probability that sum of the outputs is 8. Now writing down the complete sample space and taking those outcomes where the sum of the outputs is 8 becomes a very lengthy task. So instead of completing the sample space, let us directly understand what outcomes can give us the sum of the 2 outputs as 8. Let's say the first die shows a 6. Then we should have 2 as the output for the second die so that the total is 8. 6 plus 2 is equal to 8. Likewise, we can have 5 as the output on the first dice. Then we should have 3 as the output for the second dice so that the sum again is equal to 8. Similarly, if the output of first die is 4, then the second die should also show a 4 so that sum is equal to 8. Now if we take the output of first die as 3, then second will be 5. If 5, 3 is 8, then 3 plus 5 is also 8. And likewise, we can have 2 as the output of first dice and 6 as the output of second dice. So in all these cases, we find that sum of both the outputs is 8. 6 plus 2, 5 plus 3, 4 plus 4, 3 plus 5 and 2 plus 6. There is no other way out in which we can find the sum as 8. For example, let's say the output of first dice is 1. Then to get the sum as 8, the output on the second dice has to be 7, which is impossible. Why? Because the maximum output of a dice can be 6. So we cannot have 1 as the output of any dice. So these are the only possible cases in which we find that the sum of the outputs is 8. And we see that there are total 5 possible ways here. 6, 2, 5, 3, 4, 4, and then 3, 5 and 2, 6. Also remember, 6 and 2 and 2 and 6 are considered as two different outcomes. We should not take 6, 2 and 2, 6 as the same outcome. Why? Because here 6 is the output on first die and 2 is the output on second die. Whereas in this case 2 is the output on first die and 6 is the output of second die. Likewise, 5, 3 and 3, 5 are to be considered as two different outcomes, but not only one. But in case of 4 and 4, we have only one outcome. That is, first die has to show 4 and the second die also has to show 4. We cannot take another 4 and 4 as the possible outcome here. So total there are only 5 outcomes where we find that sum of the outputs is 8. Now the probability that the sum is equal to 8 can be taken as number of favorable outcomes by total number of outcomes. Number of favorable outcomes are 5. And we very well understand that total number of outcomes will be 6 square, that is equal to 36. So the answer here is 5 by 36. So this is how we can solve questions related to getting a particular sum as the output of the two dice when they are rolled together. We only need to check all those outcomes where we can get the sum as given in the question. And then that divided by the number of total outcomes will give us the required probability. In some bank exams, a 5 marks question is asked on probability where some data regarding a number of objects is given followed by 5 different questions based on probability. So let's discuss an example of a 5 marks question. The question here says a box contains 6 red, 4 blue, 2 green and 3 yellow marbles. So this is the data given regarding the number of objects. We have got different colored marbles here. 6 red marbles, 4 blue marbles, 2 green and 3 yellow marbles. So altogether we can see that we have 6 plus 4, 10 plus 2, 12 plus 3, 15 marbles. Now the first question here is, if 4 marbles are picked at random, what is the probability that 2 are blue, 1 is green and 1 is yellow? So very clearly, out of these total 15 marbles, we need to select 4 marbles. And what will be the probability that out of these 4 marbles, 2 are blue, 1 is green and 1 is yellow? Now as you can see here, we are trying to pick up the marbles at random. So this is a case of selection. We are only selecting the marbles and we are not arranging them. And selection is nothing but a combination. So we need to use the concept of combinations, that is NCR, to find out the required probability. We know that probability of any event can be taken as number of favorable outcomes divided by total number of outcomes. Now here the favorable outcome is that out of total 4, 2 have to be blue marbles, 1 should be a green marble and 1 has to be a yellow marble. So let us see what are the number of favorable outcomes divided by total number of outcomes to get the answer for this case. Now here we have to select 2 blue marbles and total there are 4 blue marbles. So this can be done in 4C2 ways, that is selection of 2 blue marbles out of total 4 blue marbles. Then we need to have 1 green marble and total we have 2 green marbles. So 1 green out of 2 green marbles can be selected in 2C1 ways. And similarly 1 yellow marble has to be picked up out of total 3 yellow marbles and that can be done in 3C1 ways. So 2 blue marbles can be selected in 4C2 ways, 1 green marble can be selected in 2C1 ways and 1 yellow marble can be selected in 3C1 ways. And all these 3 have to be done together. So we need to go for principle of multiplication. That is 4C2 into 2C1 into 3C1 divided by the total number of outcomes. Now total number of outcomes here is nothing but the number of ways in which 4 marbles can be selected out of the given number of marbles. We know that total number of marbles are 6 plus 4, 10 plus 2, 12 plus 3, 15. So we have to take the total number of outcomes as the number of ways in which 4 marbles can be selected out of 15 marbles. We know that selection of 4 marbles out of 15 can be done in 15C4 ways. So the probability that we get 2 blue, 1 green and 1 yellow marble is nothing but 4C2 into 2C1 into 3C1 divided by 15C4. So by simplifying this, we can find out the required answer. But remember friends, in some cases the options are given in terms of NCR. So this itself can be taken as the answer. Otherwise, we need to go for further simplification to find out what is the correct answer. Let us here do the complete simplification and see what is the probability. 4C2 is nothing but 4 into 3 divided by 2 into 1. 2C1 will be equal to 2 and 3C1 is equal to 3. Divided by 15C4, that can be taken as 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1. We are taking this based on the concept of NCR. We know that NCR is equal to n factorial divided by n minus r factorial into r factorial. We had learned this in case of permutations and combinations. So going by that, we can say 15C4 is 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1. Now by simplifying this, we can get the required answer. So 2 and 2 here gets cancelled, 4 here goes 3 times, again 3 and 3 gets cancelled and 2 can be taken 7 times. So the final answer is 4 into 3 into 3 divided by 15 into 7 into 13. 15 into 7 into 13. Now 3 here can be taken 5 times. So this is 4 into 3, 12 divided by 5 into 7 is 35 and 35 into 13 can be taken as 455. So 12 by 455 is the final answer for this question. So depending on the options, either we can take this as the answer or we can simplify it further to get 12 by 455 as the answer. So this is how we can solve such questions based on combinations. You can see that probability here is nothing but number of favorable combinations by total number of combinations. Let us now take the second and third question based on the given data. Now again the data here says a box contains 6 red, 4 blue, 2 green and 3 yellow marbles. The second question says if 3 marbles are picked at random, what is the probability that all are red? So here we are selecting 3 marbles out of the given number of marbles and we need to find out the probability that all these 3 marbles are red. Now we know that probability here is nothing but number of favorable combinations by total number of combinations. Now favorable combinations here must be all 3 marbles to be red. Now we have got total 6 red marbles and if we want 3 red marbles we can select that in 6C 3 ways. Divided by total number of combinations is nothing but the number of ways in which 3 marbles can be selected out of the given lot. Here we have total 15 marbles. So the number of ways in which 3 marbles can be selected out of 15 is 15C3. So the answer for question number 2 here is 6C3 divided by 15C3. Likewise, the question may say that all 3 marbles have to be blue. So there we need to select all the 3 marbles from 4 blue marbles. So there the answer can be taken as 4C3 by 15C3. Or it can say that all 3 have to be yellow. So we can take it as 3C3 by 15C3. So depending on what type of marbles have to be selected, the questions on probability can be answered here. Let us now look at the next question. If 2 marbles are picked at random, what is the probability that both are yellow or both are green? So here we are selecting 2 marbles out of total 15 marbles. And we need to find out the probability that either both are yellow or both are green. Remember friends, whenever we use the word or in case of probability, it means plus. So we need to find out the probability of both yellow plus probability of both green. So probability of both yellow marbles plus probability of both green marbles. Please do not waste your time in writing down all these steps in the exam. Directly take down the required answer. Now both yellow marbles, we need to select 2 marbles such that both are yellow. Total we have got 3 yellow marbles. So this can be done in 3C 2 ways divided by total number of ways 15C2 plus we have got total 2 green marbles and we need to select 2 green marbles. So that can be done in 2C 2 ways divided by again 15C2. So this can be taken as 3C2 plus 2C2 divided by 15C2. 3C2 is nothing but 3 and 2C2 is 1 divided by 15C2 can be taken as 15 into 14 divided by 2. So this goes 7 times. So the answer here is 3 plus 4 divided by 15 into 7, 105. So 4 by 105 is the probability where both the marbles are yellow or both are green. The fourth question here is that if 2 marbles are picked at random, what is the probability that none is yellow? So here we need to select 2 marbles out of the total 15 marbles, but make sure that none of the 2 marbles is yellow in color. Now out of the total 15 marbles that we have, we know that 3 marbles are yellow in color. So while doing the selection of 2 marbles, we should not consider these 3 yellow marbles. Why? Because we need marbles which are not yellow in color. So these 3 should not be taken into consideration. That means we can select 2 marbles out of red or blue or green marbles. Now we have 6 red plus 4 blue plus 2 green. That is total 6 plus 4 plus 2 is 12. So out of these 12, we can take any 2 marbles and we'll see that there are no yellow marbles there. Why? Because yellow have not been considered. So we can say that the answer for this one is 12C2 divided by total number of selections is 15C2. So by simplifying this, we get the answer. So whenever we see that a number of marbles have to be selected in such a way that one particular color is not obtained, we simply leave those colored marbles in doing the required number of selections. So from the remaining 12, we have to select 2 marbles, which can be done in 12C2 ways, divided by total number of selections is 15C2. Why? Because total marbles are 15 and we have to select 2 of them. The question here is, if 3 marbles are picked at random, what is the probability that at least one is blue? Now here again we have a different condition. At least 1 marble out of the selected 3 marbles has to be blue. So let's see how can we get the answer for such a case. Now here we know that we are selecting 3 marbles. Out of 3 marbles, at least 1 has to be blue. So we can have various cases possible. That is 1 blue marble and 2 marbles of other colors, or 2 blue marbles and the 3rd marble of some other color, or all the 3 marbles can be blue. So we have total 3 cases here. So we can say that probability of taking 1 blue and 2 of other colors, or probability of 2 blue marbles and 1 marble of other color, or probability that all the 3 are blue marbles. So in all these 3 cases, we see that at least 1 marble is blue, 1 blue and 2 of other colors, or 2 blue and 1 of other color, or all the 3 are blue. We cannot go for more than 3 marbles. Why? Because total we are selecting only 3 marbles. So we have to find out the probability of each one of them and add them to get the required answer. Why? Because or always means plus. Now when we have to select 1 blue marble, we have total 4 choices. So 1 blue marble can be selected in 4C1 ways. Into, now we need to take 2 marbles of any other color but not blue. Now if we leave these blue marbles, the remaining marbles are 6 plus 2, 8, 8 plus 3, 11. Now out of the remaining 11 marbles, we can select any 2 marbles. So that can be done in 11C2 ways. Divided by total number of ways of selecting 3 marbles is 15C3. Why? Because total there are 15 marbles here. Let me repeat once again. We want 1 blue marble and 2 marbles of other colors. So 1 blue out of 4 blue can be taken in 4C1 ways. And then we need 2 more marbles of other colors. Other colors here can be red or green or yellow. So total choices is 6 plus 2, 8, 8 plus 3, 11. So out of these 11 we can take any 2. So 4C1 into 11C2 is the number of favorable combinations, divided by total number of combinations is 15C3. Why? Because total we have got 15 marbles here and we need to select 3 out of them. Plus the second case, we have to take 2 blue marble and 1 other colored marble. Now 2 blue marbles can be selected in 4C2 ways. Into 1 marble of other color can be taken in 11C1 ways. Why? Because we know that there are 11 marbles of other colors, divided by total number of combinations is 15C3. Plus the last case, that is all the 3 marbles can be blue. Now all 3 blue can be done in 4C3 ways. Why? Because total we have got 4 blue marbles. So 4 we have to select 3, 4C3 divided by 15C3. And here we need not take any other marble. Why? Because we have already got the required number of marbles, that is 3. So when all 3 have to be blue, total number of blue marbles are 4. So 4C3 is the number of favorable combinations divided by 15C3 is the total number of combinations. So by simplifying this, we get the probability for the given question. So this is the direct way of solving a question where at least 1 marble of a particular color has to be selected. But we also have an indirect and a shortcut way of getting the answer for such questions. So let's see how to get the answer in an indirect method. We know that probability of success is equal to 1 minus probability of failure. So here, instead of taking the probability of at least 1 blue marble, we can take it as 1 minus probability of no blue marble. Why? Because at least 1 means there should be one blue marble or two, or all the three have to be blue. So from total probability, if we subtract the probability of getting no blue marble, then we get the required answer. So instead of taking probability of at least one blue marble, we can take it as 1 minus probability of no blue marble. That means out of the 3 marbles that we have selected, there should not be any blue marble. So the answer here can be taken as 1 minus probability of no blue marble. Now here we are selecting 3 marbles and we need to take the probability that out of these 3 marbles there is no blue marble. So when we are selecting 3 marbles and we don't want any blue marble, we need to leave out these 4 blue marbles. So remaining marbles are 6 plus 2, 8, 8 plus 3, 11. So out of these 11 marbles, we need to take any 3. And in such a way, we get no blue marbles. Here it can be taken as 11C3 as the favorable combinations, divided by total number of combinations. Total number of combinations is nothing but selecting 3 out of all 15. That can be done in 15C3 ways. So this is the answer for this question. So either we can take the direct way of solving the question where we take 1 blue or 2 blue or 3 blue marbles. Otherwise, it can be taken as 1 minus probability of getting no blue marble. So simply remember that probability of at least 1 is nothing but 1 minus probability of none or probability of no blue marble. So either you solve it in this way or in this way, the answer remains the same. So this is how we can solve a 5 marks question from probability by taking it as number of favorable combinations by total number of combinations. Let us now take the fourth model from this topic of probability, where we shall take up some typical questions from this topic. Let's have a look at the first one. The probability that Rohan can solve a question is 3 by 4 and the probability that Sohan can solve it is 5 by 8. What is the probability that the question gets solved if both of them try it? So here we have two persons, Rohan and Sohan. Now the probability that Rohan can solve a particular question is 3 by 4. That means probability of Rohan being successful is 3 by 4. And the probability that Sohan can solve it is 5 by 8. So the probability that Sohan is successful is 5 by 8. Now if both of them together try, what is the probability that the question gets solved? Now as given in the question, let's say probability of Rohan being successful is equal to 3 by 4. So from this we can say that probability of Rohan's failure can be taken as 1 minus probability of Rohan's success, that is equal to 1 minus 3 by 4, which comes out to be 1 by 4. So probability that Rohan can solve the question is 3 by 4. Probability that Rohan fails in solving the question is 1 by 4. Likewise, probability of Sohan's success is equal to 5 by 8 as given in the question. So from this we can say probability of Sohan's failure is 1 minus probability of Sohan's success, that is 1 minus 5 by 8, which comes out to be 3 by 8. So we now have the probability of both the person's success and probability of the failure of both these persons. Now as given here, both of them try solving the question and we need to find out the probability that the question gets solved. Now here we have different cases in which the question can get solved. For example, let's say Rohan is successful in solving the question and Sohan fails. So anyhow we have got the solution for the question. Likewise, if Sohan is successful and Rohan fails, even then we have got the solution for the given question. And if both of them are successful in solving the question, still we get the solution for the given question. So there are 3 different cases. Rohan can solve, Sohan cannot solve, or Sohan can solve, Rohan cannot solve, or both of them can individually solve it. So we can take the answer as the required probability can be taken as Rohan should be successful. Now when Rohan has to be successful and Sohan has to fail, we should take probability of Rohan's success into probability of Sohan's failure. Or that is nothing but plus Sohan solves the question and Rohan fails in solving the question. So that should be taken as probability of Sohan's success into probability of Rohan's failure. Or the third case possible here is both of them are successful in solving the question. So Rohan will be successful and even Sohan is successful in solving the question. So these are the 3 ways in which the question can be solved. So now the answer can be taken as, we know probability of Rohan's success is 3 by 4 into probability of Sohan's failure is 3 by 8 plus probability of Sohan's success is 5 by 8 into probability of Rohan's failure is equal to 1 by 4 plus probability of Rohan's success again is 3 by 4 into probability of Sohan's success is 5 by 8. Now by simplifying this we get the required answer. So the LCM here is equal to 32. Why? Because 4 into 8 is 32, 8 into 4 and again 4 into 8 gives us 32. Now 3 into 3 is 9 plus 5 into 1 is 5 plus 3 into 5 is 15. So we get total 29 by 32. So that's the answer for the given question. That means the probability that the question gets solved if both of them try it will be 29 by 32. So the important point to be observed here is, in such cases, when we take one person's successful probability, the other person's failure probability also has to be considered. Now the other way of solving the question, instead of going it in this manner, the other way of solving the question is the probability of success, that means the required probability, can be taken as 1 minus probability that the question doesn't get solved. That means 1 minus probability that both of them fail, both the persons fail. We know that total probability is always 1. So from this total probability, if we subtract the probability where both of them fail, we get the remaining probability, that is where at least one of them is successful. So we can say that the answer can be obtained by taking it as 1 minus probability of both failure. So that can be taken as 1 minus probability of Rohan's failure is 1 by 4 into probability of Sohan's failure is 3 by 8. So that comes out to be 1 minus 3 by 32, and upon simplification we get 32 minus 3, that is 29 by 32. So either we can take this as 29 by 32, or we can directly take here 1 minus probability of both the persons being failed is equal to 29 by 32. And as you can observe, this is a smart way of solving the question where we get the answer in just one step. Whereas here, we need to take all the three possible cases, find out their probabilities and add all of them to get the required answer. Let us now take another interesting example from model 4. The question says a bag contains 5 red and 4 green balls, and another bag contains 3 red and 7 black balls. If a ball is drawn from each bag, find the probability that both are of different colors. So here we have got 2 bags. The first bag contains 5 red and 4 green balls, and the second bag contains 3 red and 7 black balls. We have to pick up a ball from each of these bags, and we need to find the probability that both are of different colors. As given here, bag 1 contains 5 red balls and 4 green balls. Likewise, bag 2 contains 3 red and 7 black balls. Now we have to select one ball from bag 1 and one ball from bag 2 in such a way that both are of different colors. So what is the probability for this to happen is the question here. Now we know that if you want both the balls to be of different colors, the possible cases are red ball from bag 1 and black ball from bag 2, or green ball from bag 1 and red ball from bag 2, or green ball from bag 1 and black ball from bag 2. These are the 3 different cases in which we see that both the balls are of different colors. Now instead of taking these 3 cases, again we can take this as 1 minus probability that both the balls are of same colors. The question here says probability that both are of different colors. Probability of both balls being of different colors. Probability that both are of different colors can be taken as 1 minus probability that both are of same colors. Why? Because we know that the total probability is always 1. So instead of taking the probability of both the balls to be of different colors separately for all the cases, we can simply take it as 1 minus probability that both the balls are of same color. That means the ball that we take from bag 1 should be of same color as that of the ball we take from bag 2. Now if you try to observe, the only possible case where we get both the balls are of same colors is red ball from bag 1 and red ball from bag 2. Why? Because that is only the common color in both the bags. So we have to see to it that we pick up red ball from bag 1 as well as red ball from bag 2. So the answer here can be taken as 1 minus. Now red ball from bag 1, we know that total there are 5 red balls. We need to select one of them. So that can be done in 5C1 ways. Out of total number of balls are 5 plus 4, 9. Out of these 9 balls, 9C1. See, this is nothing but a case of combination. So we need to take the number of favorable combinations by total number of combinations. That is for bag 1. Then moving on to bag 2. From bag 2 as well, we need to take up a red ball. So here we have total 3 red balls. We have to select one. That can be done in 3C1 ways. And total there are 10 balls. And since we are selecting one, the total number of combinations can be taken as 10C1. Now by simplifying this, we get the required answer. So that is equal to 1 minus 5C1 by 9C1 is 5 by 9 into 3C1 by 10C1 is 3 by 10. So this is equal to 1 minus 15 by 90, or this is 1 by 6. So 1 minus 1 by 6 will be equal to 5 by 6. So the probability that both the balls are of different colors will be equal to 5 by 6. So this is how for these type of questions, instead of considering the various cases, we can always go for 1 minus probability of failure to get the required answer. Let us now take third example from model 4, which is again a very interesting question. Let's look at the question first. A company has two grids, grid 1 and grid 2. Out of 5 directors and 4 general managers of grid 1, one person is transferred to grid 2, which has 3 directors and 7 general managers. If one person is promoted from grid 2, then what is the probability that this person is a director? So as you can see here, we have two grids, grid 1 and grid 2. In grid 1, there are 5 directors and 4 general managers. Whereas in grid 2, we have 3 directors and 7 general managers. Now one person is transferred from grid 1 to grid 2, and then one person is promoted from grid 2. So what is the probability that the person who got promoted is a director? So let's see how to solve this interesting question. We know that there are two grids, grid 1 and grid 2. In grid 1, we have got 5 directors and 4 general managers. There are 5 directors and 4 general managers. Whereas in grid 2, there are 3 directors and 7 general managers. So these are the types of persons that we have in grid 1 and grid 2. Now as the question says, one person is transferred from grid 1 to grid 2. So initially we transfer one person from grid 1 to grid 2. And then one person is promoted from grid 2. So one person gets promotion from grid 2. So what is the probability that the person who got promotion is a director? So we need to find out the probability of the person who gets promoted from grid 2 being a director. Now here there are two possible cases. That is, when we are transferring a person from grid 1 to grid 2, it can either be a director or it can be a general manager. Whatever be the person who is transferred, it can be a director or a general manager, but the person who gets promoted should always be a director. Why? Because we are looking for the probability of the person being promoted to be a director. So there are two cases. Director is transferred and director gets promoted, or general manager is transferred but still director gets promoted. So let's find out the required answer here. That is the probability that the person getting promoted is a director. Now let's say director gets transferred from grid 1 to grid 2. And we have to transfer only one director. Why? Because the question says only one person is transferred from grid 1 to grid 2. So if that person is a director, we have to first of all take the probability of the person being transferred to be a director. Now total we have got 5 directors here. So out of 5 we need to select one. That is 5C1 out of total 9. 9C1. That means if we transfer a director from grid 1 to grid 2, the probability is 5C1 by 9C1. Why? Because total there are 5 directors. We select one and total grid has got 9 persons. Out of 9 persons we select one. Now once this director is transferred, again we have to promote a director from grid 2. Now while promoting a director from grid 2, now if you observe, there are already 3 directors in grid 2 and one more director has got transferred here. So now there are 3 plus 1, 4 directors. Out of 4 directors we need to promote one of them. So that can be done in 3 plus 1 C1 ways. Why? Because already there are 3 directors and now we have got one more from grid 1. Out of total there are already 10 persons, but one person has been transferred from grid 1 to grid 2. So now we have to take 11 persons in grid 2. So that is 11C1. So this is one case, director being transferred and director being promoted. Or the other case, that is plus. The other case here is general manager is transferred but still director is promoted. So what is the probability that general manager is transferred from grid 1 to grid 2? There are total 4 general managers. We need to select one of them. That can be done in 4C1 by total 9 persons, 9C1 ways. Into, after transferring the general manager also, we have to promote director only. Why? Because we are looking for the probability of person being promoted as a director. So now if you observe, when we transfer a general manager from grid 1 to grid 2, there are 8 general managers, but the number of directors remains 3 only. So we have to select any one of those 3 directors, that is 3C1. Divided by total number of persons in grid 2 after transferring one person will be 11. Why? Because already there are 10 persons and now one person has come from grid 1 to grid 2. So total persons will be 10 plus 1 C1. That's it. So these are the two cases that we have here. Director is transferred and director is promoted, or general manager is transferred but director is promoted. So when we transfer a director, in the grid 2 we have 3 directors already plus 1 new director. 4 we have to select one. Already we have 10 persons and 1 director is transferred. So 11 we have to select one. So 3 plus 1 C1 by 11 C1. And probability that the director is transferred is 5 C1 by 9 C1. Then in the second case, we transfer a general manager. Total 4 general managers, so 4C1, total 9 persons by 9C1. But because this is combinations, number of favorable combinations by total number of combinations. Here also, number of favorable combinations by total number of combinations. Now once the general manager is transferred, again we need to promote a director. Now there are only 3 directors now. Why? Because the person who has been transferred is a general manager. So out of 3 we need to select 1. That is can be done in 3C1 ways. But total number of persons are 10 and 1 got transferred. So 10 plus 1, 11C1. So this can be simplified as 5C1 by 9C1 is 5 by 9 into 3 plus 1C1 is 4C1 and 4C1 is equal to 4 divided by 11C1 is 11 plus 4C1 by 9C1 is 4 by 9 into 3C1 is equal to 3 and 10 plus 1C1 is 11C1, that is equal to 11. So we see that the denominator here is 9 into 11 and 9 into 11, that is 99. The first numerator is 5 into 4, that is 20, plus the second one is 4 into 3, that is equal to 12. So the final answer is 20 plus 12, that is 32 divided by 99. So the probability that the person who gets promoted from grid 2 is a director will be equal to 32 by 99. So this is how we can solve such typical questions from probability by taking the probability of each of the possible cases and adding all of them to get the required answer. So as you have observed from all these models, probability is almost based on permutations and combinations. Probability is nothing but the number of favorable combinations by total number of combinations, or it can be taken in some cases as number of favorable permutations by total number of permutations. And whatever questions we have discussed in case of permutations and combinations, all those questions can also be asked in terms of probability. We only need to take the number of favorable permutations or combinations divided by total number of permutations or combinations to get the required answer. So practice well on the questions of probability, especially on the 5 marks question that we have discussed in model 3. Why? Because that's the most popular one that we get in bank exams. That's all from this topic of probability. See you in the next session. Thank you.